In this lesson, we are going to talk about linear and circular permutation. Linear and circular permutation. These two are very, very important when it comes to permutation, and most questions are set on this. So please, you pay attention and then you get the concept once and for all. So let me say a circular permutation. A circular permutation is an arrangement of objects in a circular order. In a circular arrangement, there is no designated first or last position. There is no designated first or last position. If you rotate the arrangement, it's still considered the same arrangement. Now, this is what we mean. Let's say I have these letters A, B, and then C. Now, here to get a permutation or an arrangement, I have to rotate. They are in, let's say they are in circle. So before I can get a first permutation, I have to rotate clockwise. I can rotate clockwise or anti-clockwise. I'll get the same thing. So if I rotate from A clockwise back to A, I get A, B, C. I can also do the same clockwise rotation from B, and then I get B, C, A. And then I can also do the same clockwise rotation from C, and I get C, A, B. Now, if I also want to do counterclockwise, I'll get the same thing. Let me do counterclockwise from B. If I do counterclockwise from B, I get the same thing. So I get B, A, C. B, A, C. So you realize that the same object are obtained, but then in a different permutation. So to be able to obtain a circular permutation, you have to undergo rotation. Now let's also consider linear permutation. For linear permutation, let's say we have A, these letters A, B, and then C. So with A, B, and C, the only thing, if I want to get my first permutation or arrangement, I don't have to rotate. I only have to take the first number, then combine the other two numbers A, B, C. I take the second letter and then combine the other two letters B, C, A, and I take the last letter and then combine all different linear arrangement. Anytime I want to get a new arrangement, I just have to take and then combine them linearly. So that is also for linear this. So that's the main difference. So the main difference is that for linear, you don't have to go round, or you don't have to undergo any form of rotation to obtain a new set of arrangement. But then when it comes to circular, you have to undergo rotation to actually ensure that. So that's the main difference between that. Now, as I indicated in the circular permutation, if I take clockwise rotation, I get a new different arrangement. And if I take anti-clockwise rotation at the same point too, you realize that when I took clockwise rotation at B, from B as the initial point, I got a different permutation or arrangement. And when I took anti-clockwise or anti-clockwise rotation at B2, I got a different permutation. So to be able to get a different permutation, you have to ensure that you undergo rotation for circular permutation. Now let's see the formula to use. This is the formula to use. What you need to do is that always understand that the number of distinct circular permutation of n distinct objects is given by this, where is given by into bracket n minus 1 or factorial. N is the total number of distinct objects arranged around. So here the distinct answer were A, B, and then C. They are different, and then they were arranged around, let's say, a round table. They were arranged around a circular table. So to understand this, imagine arranging n distinct objects in a circle. First, let's consider arranging them in a line. Okay, so let's consider arranging them in a line. So let's say you want to arrange this A, B, and then C. We have arranged them in a line. There are n factorial ways to do so. You understand? There are n factorial ways to do so, because if you really want to take the number of different arrangement that can be made from this, you just have to take 3 factorial, because that's the total number. And then now imagine taking a linear arrangement ABCD and joining it end to end. Okay, so here let's say I want to take a linear arrangement of this ABC. I want to take a linear arrangement of this ABC, but here I want to join them from end to end, not linear. So I want to take this A, then I join this to B, then I also join this to A. It's not that perfect, but then you realize that a circle has been obtained. It was on a straight line, but here I'm joining them from end to end. I hope you understand. So you get this circular permutation. And with this, you have to undergo rotation to obtain a new different permutation. So that is the basic difference between linear and circular permutation. Now let's proceed and then do more examples in the next video. Thanks for watching, and let's meet in the next video. Bye.